Dear student, have discussed the factor theorem. Let's see.
The factor theorem states that for a polynomial px of degree greater than or equal to 1, x minus a is a factor of px if pa is equal to 0. In other words, if x minus a is a factor of px, then a will be a 0 of px. Conversely, if a is a 0 of px, then x minus a will be a factor of px. In general, if all zeros of the divisor polynomial are also zeros of the dividend polynomial, then the divisor polynomial is a factor of the dividend polynomial. Tap the divisor polynomials to see the zeros and the factors. Tap the buttons to understand this better with more examples. The general equation of a quadratic polynomial and its factors can be written as ax squared plus bx plus c is equal to px plus q rx plus s. Case 1. If the polynomial's highest power term, x squared in this case, has the coefficient 1, we can factorize it in the form x plus q, x plus s. That is, the x terms in the factors will also have the coefficient 1. Tap the button to understand this better with an example. Case 2. If the highest power term has a coefficient other than 1, then we must factorize it in the form px plus q, rx plus s. The degree of the quadratic polynomial is 2. Therefore, it will have two factors, say px plus q and rx plus s. ax squared plus bx plus c is equal to px plus q rx plus s is equal to rx px plus q plus s px plus q is equal to prx squared plus qrx plus psx plus qs is equal to prx squared plus qr plus psx plus qs. Now, comparing the coefficients of x squared on LHS and RHS, we get a is equal to pr. Comparing the constant terms, we get c is equal to qs. We then check the 0 of the first factor, px plus q is equal to 0. X is equal to negative q by p. The required solution is given by the factor pairs P, R, and Q, S for A and C respectively, where the values of P and Q give us a zero of our polynomial at x is equal to negative Q by P. Tap the button to understand this better with an example. Consider a polynomial ax squared plus bx plus c. Let the factors of this polynomial be px plus q, rx plus s. Now, comparing the coefficients of x squared, we get a is equal to pr. Comparing the coefficients of x, we get b is equal to qr plus ps. Comparing the constant terms, we get c is equal to qs. Therefore, b is the sum of the numbers qr and ps, and the product of these two numbers is ac as shown. qr/ps is equal to pqrs is equal to ac, as a is equal to pr and c is equal to qs. Tap the button to understand this better with an example. To factorize cubic polynomials, we are looking to find three factors. We start with the factor theorem so that we get one factor first. Then we use the splitting the middle term method to determine the remaining two factors. Tap the button to understand this better with an example. Fill in the blanks with the correct values. 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 Fill in the blanks with the correct values.
Try yourself.
Fill in the blanks with the correct values. 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 Let's summarize what we have learned in this topic.